Alright, so let's talk a little bit about amines. In fact, synthesizing amines. Um, you've actually seen this before, but I'm going to go through it anyway. One way of making an amine is you can take a primary alkyl halide. Because we want to make an amine, we want to add in nitrogen, and the best way to add in nitrogen is by adding in cyanide ion. So you go from alkyl halide to the corresponding cyanide. Alright, and once you've got that cyanide, you can then reduce it down to the corresponding amine. Now, what do you think you would put here? I'll give you a clue. It's a two-step process, and I already said it was a reduction. Well, it's the reducing agent that we've seen most often, and that is our lithium aluminum hydride, followed by, as always, protonation to form our product. Now that's one way of combining two reactions that we've seen already to make an amine. There is, however, another way. So essentially, just so everybody's clear, this is just a review of reactions that you've seen before. There shouldn't be anything new here. So here we're going to turn our OH into a good leaving group by making it into a chlorine, so we're making acid chloride from an acid. And then if we were to add in NH3 to this, we have seen this before as well, we could make an amide. Alright. And then how do you think we can get from the amide to the corresponding amine? Well, what sort of reaction is this? Well, you're losing oxygen and gaining hydrogen, of course, as above, it's a reduction. So therefore, what two-step process do you think we need here? Well, that's not really a surprise, it's exactly the same as what we had written above. Lithium, aluminum hydride, and then H3O+. I really should be more particular about this. It's actually a little lithium aluminium hydride, but whatever. So those are two ways that you've seen before that combine several different reactions that you've seen before. There is one other way to make aromatic amines, and you would have seen this in Organic 1. And it actually starts from nitrobenzene, and it goes to the one aromatic amine that you've seen. Hang on a minute, let me just erase that. And whilst I'm erasing this, you can tell me what the name of that aromatic amine is, the one with NH2 coming off the benzene ring. In other words, this. What's the name of this? Wait for it, wait for it. Of course, it is aniline. Now, what sort of a reaction is this? Well, it's very similar to this. This is a reduction, this is a reduction, and this is a reduction. But if you remember from chapter 8, aromatic molecules have a totally different reactivity to those that are aliphatic, so that implies that the reagents are going to be different as well, and in fact they are. You can make a reaction like this occur by using hydrogen gas. So you throw in your nitrobenzene, you're throwing some hydrogen gas, but you need a catalyst. And usually it's some sort of palladium on carbon. I'm just putting the word in brackets here, just so you can understand that the palladium over carbon is a catalyst. So that's three ways that you've seen before to make amines. I want to look a little bit about, well, why couldn't we do something like this? Let's say we have an alkyl halide. Here, we kind of went roundabout, we added in a cyanide and then reduced it. Why can't we just take this and add in some ammonia to make this? Let's say we aren't concerned about adding in carbons. Let's say that we want to get this. All right. Now, why wouldn't that work? You know, because in theory, at least, these electrons, which are nucleophilic, would attack there, which is an electrophile, would kick off that, and would make this. We get HBr in the process, but you know that's not a problem. Do these arrows look like something that wouldn't happen? Well, of course they don't. These arrows look perfectly fine. We get a primary amine here. But there is a reason why doing this reaction is virtually never used, although it looks to be fine. Now, I wonder if anybody can figure out what that problem is. Well, what if we had a situation, by the way, this is an SN2 reaction. Just imagine if we had a situation where you have your alkyl bromide and you add in your ammonia and you get this. The problem is that all of this and all of this are not going to react with each other all at the same time. You're always going to have some of this and some of this and some of this all in a mixture with each other. The issue that comes about is this is a primary amine. And the primary amine has a very similar reactivity to ammonia. In fact, it's the same for primary amines, for secondary amines, and for tertiary amines. So these all have similar reactivities. In other words, we use ammonia to make the primary amine. What this primary amine can then do, assuming there is some alkyl halide lying around, which in a reaction like this there certainly would be, because this has a similar reactivity to this can just go and attack this as well. Alright. So what you end up with is the primary amine that you started with, but now you've added on another alkyl group. So actually this is a secondary amine now. And then this has a very similar reactivity to this. And so the secondary amine can just do exactly the same thing and take its electrons. Well, that is actually a pair of electrons there, not a line. Bloody software. This can actually go here, attack here, and here, and so on and so on and so on. I'm just going to say and so on. In fact, the only time this stops is when you get to a point on your nitrogen where you have no lone pairs. Primary amine has a lone pair, secondary amine has a lone pair, tertiary amine has a lone pair. Now the tertiary amine can react with this again to form something you saw in a previous video, a quaternary ammonium salt, something like that. And now that nitrogen actually has a plus charge on it, and there's a Br minus, and at this point there are no more electrons on the nitrogen, so that reaction stops. However, the big deal with that is, let's say you wanted just this product. Well, you would get that product, but you'd also get this. You would get the tertiary amine product, which I haven't got shown here, but you'd also get the quaternary ammonium salt. So if you wanted one, you'd actually get 4 products. So hopefully this explains why, although this reaction in theory works, if you want just one product, because it's extremely hard to control this to prevent this from doing anything as soon as it forms, that will react to form this will react to form tertiary amine, and so on and so on and so on. So what you'll find out is, although this seems like a very simple method to make this amine, in most cases it doesn't work because it's economically not a smart thing to do, simply because first off you don't generate one single product, and then you got to figure out about separating them all, which is a pain in the bottom, so you really don't want to worry about it. Alright, that's a little bit about reactions of amines.